So where does Neutron fit in the launch industry? So guys, you know me as the largest channel dominating the electric vertical takeoff and landing space, and this has been recognised by Archer Aviation for covering them 7 days a week. But together, we're going to grow into this Rocket Lab space also. This is one of our biggest projects yet, so make sure you bang that subscribe button, as over the next week I'm going to answer 20 of the biggest Rocket Lab questions by investors in only 3 minutes each. We will be one of the largest channels when it comes to Rocket Lab. I guarantee you that. Anyway, let's get back to this question. So where does Neutron fit in the launch industry? Rocket Lab's Neutron rocket is poised to make a significant impact on the space launch industry, bringing a unique blend of innovation, capability and strategic positioning that could disrupt the current market dynamics dominated by players like SpaceX and United Launch Alliance. Neutron, as a medium-lift, partially reusable launch vehicle, aims to carve out a niche by offering a cost-effective, reliable solution for a variety of missions that require slightly more payload capacity than what Rocket Lab's current availability is with the Electron rocket. But it doesn't necessarily have the capacity of the larger rockets like the Falcon 9 or Vulcan Centaur. Firstly, Neutron's design philosophy emphasises reusability, a concept that has been proven to be a game changer in reducing the cost of access to space. With a capacity to low Earth orbit of up to 13,000 kilos in its partially reusable configuration, Neutron targets the sweet spot of the launch market, where there is a significant demand for launching medium-sized satellites and constellations. This capacity allows Neutron to serve mega constellation operators who need to deploy numerous satellites frequently but do not require the heavy lift capabilities for each launch. This focus on the mega constellation market is particularly timely given the rise in satellite internet constellations like Starlink and the growing interest in Earth observation networks, which require regular cost-effective launches. Neutron's reusability is not just about cost savings though. It also addresses the environmental concerns associated with traditional expendable launch vehicles. By designing the first stage to return to the launch site or land on a downrange platform, Neutron minimises debris in the ocean and reduces the environmental footprint of each launch. This aspect is increasingly important as space agencies and private companies face pressure to adopt more sustainable practices. The rocket's propulsion system, featuring the Archimedes engine which burns methane and liquid oxygen, further positions Neutron favourably in the industry. Methane is seen as a promising propellant for future space missions due to its potential for reusability and the possibility of producing it on Mars or other celestial bodies, thus aligning Neutron with long-term space exploration goals. The development of the Archimedes engine, with the focus on reliability and ease of production, could set new standards in rocket propulsion, offering a middle ground between the high-thrust complex engines of heavy launchers and the simpler, less powerful engines of small launchers. So guys, you're here for the market fit, but before I tell you where Neutron fits, where do you think Neutron fits best in the market? Let me know below. So this is what I'm thinking in terms of market fit. Neutron's capabilities make it an attractive option for both commercial and governmental customers. For commercial entities, the promise of lower costs per launch due to the reusability could ease the access to space, allowing smaller companies or new entrants into the satellite industry to compete more effectively. Neutron's design also supports rapid launch cadences, which is crucial for operators needing to deploy large constellations quickly. For government missions, particularly those under the programs like the US Space Force's National Security Space Launch, or the NSSL we like to call it, Neutron could serve as a medium lift option, potentially qualifying for the NSSL Lane 1, which is aimed at introducing new launch capabilities without the stringent requirements of Lane 2 missions. Neutron's physical design, including its innovative fairing that doubles as part of the first stage structure, reduces complexity and potential points of failure compared to traditional designs where fairings are jettisoned. This hungry hippo fairing system not only lowers the cost, but also simplifies recovery operations, enhancing the rocket's operational efficiency. The use of advanced materials like carbon composites for structural elements further promises weight reduction, which translates into better performance metrics or additional payload capacity. Rocket Lab's approach with Neutron also extends to its business strategy. By developing infrastructure like the new launch complex in Virginia, Rocket Lab is not only preparing for Neutron's operational needs, but also signalling its intent to be a long-term player in the US launch market. This localization of launch operations can provide strategic advantages, including quicker response times for national security launches, and foster closer ties with US government agencies. The timing of Neutron's introduction into the market is also significant, with the industry witnessing a bottleneck in launch capacity, particularly for medium lift missions. Neutron arrives at a moment where there's a clear need for additional providers to ensure launch availability, resilience, and competition. This could lead to a more dynamic market where launch prices are driven down and innovation is spurred by competition. Rocket Lab's Neutron fits into the launch industry by addressing a specific segment of the market with innovative engineering solutions focused on reusability, cost efficiency, and environmental considerations. But guys, enough about Neutron. Meet me here next to see where Electron stands in 2025.